A revolutionary AI model called MVDream is rethinking what is possible in the field of 3D modeling. It appears that MVDream is capable of comprehending physics. It succeeds compared to earlier methods. It is aware that any prospective views should only be seen with 2 ears, not 4. Just this one line of text results in the creation of a very good 3D model. How awesome is that? But how it functions is much cooler. In this video, you will get to know more about MVDream. Let's dive in. ByteDance researchers have developed MVDream Multi-View Diffusion for 3D generation, a diffusion model that can produce excellent 3D renderings from text cues. Similar models already exist, but MVDream achieves comparably high quality and does away with 2 major drawbacks of competing strategies. These frequently experience content drift and the Janus dilemma. For instance, a generated plate of waffles alters the amount and arrangement of the waffles depending on the viewing position, or a generated baby, Yoda has numerous faces. When you look at a 3D model, the biggest challenge is that each view from where you are looking at it needs to generate realistic and high-quality images, and those views need to be spatially coherent with one another. Not like the 4-eared Yoda we saw earlier or multi-face subjects, since we rarely have people from the back in an image dataset. So the model kind of wants to see faces at all costs, since we create standard photos and integrate them to create a complete 3D scene. Then, we create every conceivable perspective from the object's surroundings. We are accustomed to seeing strange artifacts like this, since the model is just trying to create one view at a time and isn't sufficiently understanding the entire item in the 3D environment. MVDream, however, took a significant step in this regard. They took on what we refer to as the 3D consistency problem, and even assert to have found a solution utilizing a method known as score distillation sampling, which Dream Fusion developed. When it comes to the hype around technology, AI is eclipsing the metaverse to grab the interest of businesses and customers worldwide. However, AI has the potential to improve the metaverse even more, at least in terms of asset generation. The production of 3D assets for usage in virtual worlds could be scaled up using AI. AI Business examines the numerous AI 3D generation capabilities. Each method has the potential to speed up the customization and creation of virtual objects and surroundings for creators, especially for individuals without previous 3D modeling experience. The creation of assets for video games and metaverse environments, as well as the development of design concepts for commercial items, are potential uses for AI 3D generation. It might also be used to generate potential mock-ups of industrial facilities by simulating factory floors. But what is that much special about MVDream? Why is it said to be the only model that has all the features for making up a 3D model? MVDream can create a 3D model that looks real with the help of data like language and images. They are already trained in a number of shapes and sizes in order to work up with the models the user needs. In essence, it leverages the trained multi-view diffusion model that we already have and freezes it. That is, it is used, but not trained. With the help of our caption, we begin by creating an initial rendering with more noise using our multi-view diffusion model. By introducing noise, we inform the model that it must create an alternative version of the image while still providing context. Next, we create a better image using the model. To utilize this result as guidance and to enhance our NeRF model for the following phase, add the source image and remove the noise that we manually inserted. However, how does MVDream perform its miracles? How does it develop from a 2D image diffusion model to a multi-view diffusion model, allowing it to provide several viewpoints of an item, and most crucially, guarantee the coherence of the 3D models it produces? This model seeks to produce multi-view graphics from a given text prompt that are geometrically coherent. The consistency of 3D data is combined with the generalizability of 2D diffusion models in MVDream by utilizing large-scale online datasets and a multi-view dataset produced from 3D components. Here are 3 key learnings of MVDream. The 3 discoveries of MVDream are multi-view diffusion, score distillation sampling, and personalized 3D generation. Do you wonder what all these things are? Multi-view diffusion is basically a collection of multi-view photos produced by MVDream that are consistent with one another. In order to inherit their generalizability, It incorporates transfer learning models that have already been trained and built upon the architecture design of 2D image diffusion models. In order to achieve strong consistency and generalizability, MVDream renders multi-view images from a genuine 3D dataset. While score distillation sampling, MVDream resolves the 3D consistency issue, improving the stability of the two delifting techniques now in use. It employs score distillation sampling for 3D creation under multi-view supervision from the diffusion model. This enables MVDream to produce unexpected and fictitious 3D content that is specified by text input. And the configuration for customized 3D generation allows for fine-tuning under a few shots. After fine-tuning, it retains multi-view consistency while assimilating identification data from a series of supplied photos. This qualifies MVDream for programs like DreamBooth 3D. The AI revolution is creating new innovations in order to make things easier and more productive. MVDream will play a major role in creating several 3D models that will help in individual personal use and also in graphic design. So, do you wonder how this MVDream works? They are generally divided into different steps and processes in order to create a 3D model. It takes these steps to carve out the specific model you need. These steps include the major component of the 3D image processing, namely NERF. A particular kind of neural network called a neural radiation field can be used to encode and create realistic 3D scenes from a set of 2D photos. NERFs are trained on a collection of pictures that were shot from various angles of the same scene. Each pixel in the photos is taught to correspond to a point in three-dimensional space by the neural network. As a result, the neural network may create fresh perspectives of the same scene from any angle. Compared to conventional methods of 3D scene representation, NERFs provide a number of benefits. They can be utilized to provide fresh perspectives of the area in real time and are capable of accurately representing complicated scenes in great detail. NERFs are, therefore, well-suited for a range of uses, including 3D printing, augmented reality, and virtual reality. The resulting multi-view diffusion model may accomplish both the generalizability of 2D diffusion and the consistency of 3D data by utilizing image diffusion models pre-trained on massive online datasets and a multi-view dataset produced from 3D components. A model like this can be used as a multi-view prior for 3D generation using score distillation sampling, where it considerably enhances the stability of current 2D lifting techniques by resolving the 3D consistency issue. Last but not least, we demonstrate how the multi-view diffusion model can also be adjusted in a few shot settings for customized 3D generation. That is the DreamBooth 3D application, where consistency can be maintained after learning the subject identity. Training with 3D data that would not be accessible at the needed scale is not necessary for 3D generation. Instead, DreamFusion uses 2D photos of an item created with Imagen from various angles to learn the 3D representation. For this, the research team utilized gaze-dependent prompts like front view or rear view. It happens automatically. This new method still has certain drawbacks, chief among which is the poor resolution of the generations, which is just 256 x 256, despite the amazing appearance of the outputs. The size of the dataset used for this assignment, which is considerably too tiny to accurately depict our complicated world, is also mentioned as a restriction on the generalizability of the approach. As the dataset of MVDream is only trained with specific features and sizes, if we ask for more complicated products, it won't be able to provide the correct output. These are the current issues that MVDream faces. This can only be resolved by any other highly developed AI innovation that has the ability to provide with the needs of the users. But at present, there is no need to invent a new AI 3D creator. Do you think there is a need for another model that fixes all these drawbacks? Share your opinions and thoughts with us, and that's all about it. If you find this video informative, please give a thumbs up, and if you like more updated AI news, subscribe to our channel. And don't forget to click on the bell icon to not miss out on any video and to get notifications on time. Don't hesitate to give suggestions for our videos. See you in the next one.